Hello everyone. Our team has come up with a project, Movie Recommendation System. What is recommender system? So recommender systems can be understood as systems that make suggestions. We often ask our friends about their views on recently watched movies. So based on that, we decide whether to watch the movie or drop the idea altogether. Imagine if we get the opinions of maximum people who have watched the movie. We also get ideas about similar movies to watch, ratings, reviews, and the film as per our taste. The selection of movies would become so easy using this recommender system. So that is what recommender systems usually do. They help us make selection, narrow down our research, and enjoy the selected list of movies without wasting time in searching for which movie to watch. We have seen our classic example of movie recommender or any shows recommender, that is Netflix. This is an classic example for this. In this project, we will be just building a simple recommender system. For this system, we have taken data set from Kaggle. So here we go. It's a 5000 movie data set. Here we found TMDT 5000 movie dataset, and the two dataset would be downloaded. The two CSV files, credit.csv and movies.csv. Now we come to our directory where we will be working. We have to upload the two datasets here. I have uploaded both the datasets, credit.csv and movies.csv. And my file is already running here. I will just walk in through this file. So we start with the importing basic libraries, that is NumPy and Pandas. And the second step is download the dataset by creating an object df1. It will read the CSV file, that is credit.csv, and we see the first five entries of the df1 data frame. These are the first five entries, and here there are four columns: movie ID, title, cast and crew, as we can see it here. Now we see the shape of the data set. It contains 4803 rows and 4 columns. And if you see the information of this data set, we can see it contains columns, null value and data type. Columns are movie ID, title, cast, crew, and we can see there are no null values, and the data types are integer and object. Now we load the dataset for second data frame, that is movies dataset, and it is converted into data frame, and we see the first five entries here of this dataset. See, we see here budget, homepage, ID, keywords, original language. So there are many such things: production companies, production countries, release date, revenue, tagline, title, vote average, vote count. As we see the shape of this data set, it contains 4803 rows and 20 columns. And so if we look into the information of this data frame, second data frame, you can see it contains columns and null values and also data type. Columns are given here. There are 20 columns and null values also. Here we can observe that home page has some null values, and even tagline has a null value, then rest don't have. And data types are integer, float and object. Now we need to merge the two data sets, two data frames, and I will merge these two data frames on column ID because it is the same on both the data sets. So for that, we have created an object that is df1 columns, in which we will have four columns: ID, title, cast, and crew. That is what our dataset had, df1 dataset. And on df2 dataset, we will create an object, and in this we will merge the df1 on what ID, because IDs are both same for both the datasets. After merging, if we check the df2 data frame, that is df2 dot head, we will which will give the first five entries of this data frame, and we see this there are 5 rows and 23 columns. It's mentioned here 5 rows and 23 columns, that is 4 columns have been increased now. So they are from the first data frame: title, cast, and crew. So the last 3 columns, title, cast, and crew, which was the first data set, it has been concatenated or merged. Okay, now let's understand what actually we are doing here. We want to dig into this data set and derive some meaningful information from this. For this, what we have to do is we want to find some metric for rating the movie. So if a movie has a good rating, then I will recommend that movie, right? So if it is a good movie, it will have high rating and vice versa. For that, we need to calculate score for every movie so that it can be easily analyzed, and we have to sort these scores and recommend best rated movie to the users. So this is how we go through it. For this, we go with the IMDb's weighted rating formula. As you can see here, weighted rating formula, WR equal to V divided by V plus M dot R plus M divided by V plus M dot C. So here V is the number of votes for the movie, and M is the minimum votes required to be listed in the chart, and R is the average rating of the movie, and C is the mean vote across the whole report. Now we'll go back to the data set, that is Jupyter Notebook, and we'll see how to calculate C. So it's here given the columns here and the shape of the DF2 data frame, and we'll see how to calculate the C. So what do we want for our DF2 data set is we calculate the volt average mean here. Since we have volt average mean, we will find the volt average mean of it. Since we have volt average, we will find the mean of it. See here, we can see here volt average. We will find the mean of it, and that gives us a value of 6.09. So that means it roughly on the scale of 10, all the movies are rated as 6. That is the mean average. But how we recommend these movies to user, which movie is best or popular? So what do we do is we find the minimum votes so that we can eliminate some movies from our chart. So the next step is to find the minimum votes to be listed, and for that again we create a variable object, and in that we take a vote count. You can see in this vote count, it's in the column itself, and we take the quantile 0.9, means we take quantile 90 because we want only those movies which must have more votes than at least 90% of the movies in the list. That's why we are giving as a quantile 90, and when we find it, it gives as a 1838.4. This is the minimum value which can include in our list of movies for recommendation. So the next step is getting the list of these movies to be listed after filtering, like a minimum votes to be listed, right? After filtering that, getting the list of the movies to be listed. So for that, again, we create one object list movies and make a copy of the data frame 2, that is df2, and we give a condition that here if word count is greater than or equal to the minimum value, that is 1838.40, here is given 1838.40, then we include that movie in the list. So we can see that if we see the shape of this data set, now it includes 481 movies in the list. So now we have got a new list of movies, that is high rated movies as per the formula. So now what to do is we have to get this thing in a data set in this table, right? So we need to define a function that is weighted rating, and in this x is every it's like every movie, and m is the minimum votes, and c will be the vote average mean of the entire movie. And we create v and r which are needed in this formulas, that is weighted rating formula, and V would be the vote count, R is the vote average, and based on IMDb's formula, we return the formula here. Here M equal to 1838 and C equal to 6.09, which we have got. It's taken as a reference. So now again moving further in the list of movies, the score, which is the column, here need to be added, where we apply the weighted rating, and axis is fun. You can see here axis is fun, that is in this column. So when we see this head, the content in this frame, the list of movies, you can see here score is added here. So now it contains 481 rows and 24 columns. One extra column is added, that is the score part. Since we have this entire data, rows and columns, we will sort these movies according to score, which will be easier to understand which movie will ranks the first. Okay. So now we again in this object list movies which was created earlier, we will apply the sort value, and ascending is false. So the highest movie rating would come here. So now we will just see the first 10 movies, and columns taken for that are title X, vote count, vote average, and score, which are important parameters. So that's why we have taken these 4 columns. You can see the first 10 entries. So here Inception is the highest rated movie, and Dark Knight, Interstellar, Flight Club. So the movies are listed as per the score in descending order. This is a basic recommender system, but there is one more step, that is popular movies. So what happens is that if we want to go to some websites or tab, and we see trending videos in the tab, and we see the most popular movies, the scroll down list will come, right? So how do we get that? For that we need to make these steps. We will create an object pop, and in that we go with the popularity, which is given in the data set itself. I will show you. See, popularity, we will take this parameter popularity, and according to popularity we want the movies to be listed so that we can select the most popular movie. So we sort it here, we see the 6 most popular movies here, and this is just going to the nitty-gritties of plotting the matplot horizontal bar graph, we have given title, label X and Y axis, and as per popularity, we are getting these movies like Minions, Interstellar, Deadpool. All these are popular movies. Now, another thing is we can just play around with this feature. Instead of popularity, we can give here budget also. It's been given in the data set budget. Yeah. So instead of popularity, I will give now budget. You can see the high budget movies, Pirates of Caribbean, On Strangers, Tides, etc. are there. And we can change this 10 or 15. We can give anything. Instead of 6, we can give 10. It will give a 10 list of movies, top 10 movies. So we can give it as per our choice of recommendation, and we can experiment with these features as per our choice, that is based on popular movies, budget, and again I have given here revenue. So depends on revenue. Um, you can see the list of movies. So now if you want to select any thriller or horror movies, we need to define a more defined system for this. So that is what the next program is about, called content based filtering to this recommender system. So content based filtering means whatever description have given of data or movie or any item, we take that as a content, and based on that description recommenders are made. So the advantage of this is that when sufficient data not available, or even if we got few items with no history of ratings, still recommendations can be made. When I just explored the data set, I discovered that this title was redundant. So I dropped this title Y, which was same as the title X. So now our shape should be like 481 rows and 23 columns. We have just dropped the redundant title. See how does our data set look like? We have budget, genre, home page, ID, keywords, and some other more columns. Now we will make content based recommendation. So I'll use column overview here, which is a description of movies like Avatar movie and its description, Pirates of Caribbean and its description. So based on these descriptions, we will find out how movies are similar to each other and will make the recommendations using the overview. Now we will see this overview column and the top 10 entries in it. So this is the description of the top 10 movies overview. Next, um, now we will be using TF-IDF vectorizer, that is two terms. TF is term frequency and inverse document frequency. So TF means number of times a word appears in document divided by the total number of words in the document, and the second term, inverse document frequency, is computed by taking the log of it. So basically, term frequency measures how frequently a term occurs in a document, whereas in inverse document frequency means how it measures how important a term is. Computing term frequency, all terms are considered equally important. So few terms like and, the, is, of, so they might appear many times but are of little significance, right? Hence, we need to weigh down the frequent terms while we need to scale up the rare ones. That we don't have to go through the nitty-gritties of this, because SQL and Python library will already have all this TF-IDF vectorizer, which will make us the things easier. What we do is we define a vectorizer object and remove these stop words, that is English, and we have got some certain empty values. We will be replacing it with an empty string here, fill n, and we will construct a matrix and we will fill it, and transform this overview in this matrix, and when we print the shape of it, we find that there are 4803 rows, that is the movies, and 20,978 columns, that are the words which makes the entire description of the movies. Now we have got a matrix which is being plotted in a space like 3D. We will find the similarity. To compute similarity score, there are several ways such as Euclidean, Pearson and cosine similarity score. Here we will use cosine similarity to calculate the numeric quantity that denotes similarity between the movies. So we use it because it's relatively easy, fast to calculate, and also it's independent of magnitude. We use linear kernel since it is faster. sklearn we will import linear kernel, we'll pair it, and next we will compute the cosine similarity matrix by creating an object, and we are going to define the function that takes in movie as an input and outputs a list of top 10 movies. For that, firstly we need to reverse mapping of the movie titles, data frame indices, and given its title. So we will also remove the duplicate values because duplicates will be formed when we do the mapping of it. Here it will take the inputs of the movie which will give, and it will return 10 similar movies based on the cosine similarities, and we will get the index of the movie that matches the file, and we get the pairwise similarities of all the movies with that movie, and then we sort the movies based on the similarity score. Here we are using an anonymous function lambda. It will take input x and then return the first element, that is x of one first element, and then it will take the score of the 10 similar movies that get the indices, and then it return the top 10 similar movies. This is how we run the entire function. Then we can simply use the function here, get recommendations, and give the movie name. I run this, I get the top 10 movies: Dark Knight, Batman Forever, Batman Returns. So in this way, if we give any movie, we will get the top 10 movies. So based on the similarity, especially using the overview, that is description of the movies. About our project, movie recommendation system. Thank you.